we've looked at ray tracing with lenses. Now we're going to start with mirrors. So first I'm going to start with a convex mirror. And I'm going to save myself a little bit of work, but I'll come back to that in a second or show you how. With a convex mirror, we have a sphere like this. And I just want to look at what's going on with it before I really dig in. So we have a sphere like this, and if I've got a principal axis that kind of passes through the middle of it, if I stick some light rays on here, I might have a ray that comes in like this, and when it comes in like this, it sees this surface and it bounces off of it. It'll bounce something like that. So there's my outgoing ray. I might have a different ray over here that comes in, and it sees this surface and it bounces off of it, and it'll bounce something like that maybe. And as you can see, these rays are not going to cross each other, so if we trace these back, because that's our other move, it looks like these rays are coming from this location. This would be the focal point of a convex mirror. So for a convex mirror, the focal point lies somewhere inside the mirror. And conveniently, that focal point is always going to be at half the radius of the mirror. So now, because it's a little bit more finicky, I do want to take a second and draw this thing well. I'm going to pause my recording and start drawing, and the next time that this picks up, it's going to have a picture kind of already set for you. That passes through the middle of my mirror, and then this location is my focal point. I'm giving myself a focal length of 15 centimeters, but my focal point, as I saw, was made by light rays not actually converging, just looking like they originated here. So this is a virtual focal point of -15. And now I need an object. I'm going to put my object at 30 centimeters, and I'm going to give it a height of 9 centimeters. So there is my object. I'm saying my object distance is 30 centimeters. My object height is 9 centimeters. And I want to see what I can do with that. Now with a mirror, the big difference between a mirror and a lens is that I don't have an F and an F prime, I just have an F. So let's see what that means. Ray 1 is going to go parallel to my axis and then through F. Parallel to my axis until it hits. This is why the geometry of the lens, or of the mirror, was so important. And then through F. Of course, what's really happening is that that light ray is bouncing out. There is ray 1. It exits off the mirror, and then I could trace it back, and I will, but not yet. Let's keep moving forward. Ray 2 is going to go through F prime and then parallel, but like I said, for a mirror, F and F prime are the same thing as each other. So now I'm going to go as though I'm going to go here. So I'm going from my object to the mirror, and then I'm bouncing off this thing. So that way, there's my ray 2. Ray 1 and ray 2 are not going to meet up with each other, so I need to be able to trace these things back. Here we go. Ray 1, I'll trace back with, again, a slightly different color. And there's what ray 1 prime would be doing. Ray 2, I'll trace back with a slightly different color. And 3 dots up, and 3 dots up. So there is what ray 2 would have been, ray 2 prime, and I end up with an image that is right here. My image is upright, and it's going to take me just a second to figure out exactly where this thing is, but that's not too bad. I'm going to trace my image back, and that looks like it's here, which means my D image is at 10 centimeters. I do not have outgoing rays making that. I have a negative image distance. I have an image height of 1, 2, 3. So I have a virtual upright image, and it is reduced. I'll get rid of this background. A virtual upright reduced image. I'm going to figure out my magnification. My magnification is HI over HO is 3 centimeters over 9 centimeters equals positive 0.33. And I want to try it again. Negative DI over DO. This is just a consistency check right now. So I get a negative 10 over 30 is a positive 0.33. That checks out. For a convex mirror, I'm always going to be outside my focal length. I can't really do a different thing because my focal point is over here inside the mirror itself. I can't stick my object inside the mirror itself. So this situation is actually the case for a convex mirror no matter where I place my object. If I would have placed my object, over here, I would have ended up with an image over here. It would have still been inside the mirror. Little different size, but this is the same process every time. So once you've solved one convex mirror, you've really solved them all.